What's up, guys? It's Chi again, and y'all are welcome to another knowledge field Chi analysis lesson. We are still going to have a nice time in this lesson as I will be taking you through the different types of loads that act commonly on civil engineering structures. I hope you're ready. Now, what do we know about loads? From the previous lesson, we know that loads are external forces acting on a body. We also saw that loads causes deformation in structures, as we saw in the ropeline example. Now, analyzing the ropeline example, we saw that the duvet was a load, which is the external force that acted on the body. In this context, the body is a ropeline. Our major concern is the duvet, which is a load that acted on the ropeline. Now, the word duvet isn't just any kind of load. It is classified under a particular type of load, which is our major concern for today's topic. Before the end of this lesson, we'll be able to identify what type of load the word duvet is. That brings us to the topic for today: types of loads that act commonly in civil engineering structures and how they are classified. First, we're going to look at our structural loads. Now, under structural loads, we have so many loads, but the most important loads are dead load, live load, and environmental loads. I cannot give you all the types of loads. So I'm going to concentrate on the most important ones, or rather the most common ones. We have dead load, we have live load, we have environmental loads. Under environmental loads, we have wind loads, earthquake loads, earth pressure, and snow loads. So I'm going to be expatiating on all of them, especially the dead and live loads. So when we talk about dead loads, we mainly refer to permanent loads. That's the keyword. That's what I want you guys to note, the word permanent. So anytime we talk about dead loads, they are permanent loads. They are static, they are stationary, they are immovable fixtures. These loads occur due to the self-weight of the structure. Now, what makes up the self-weight of the structure? The structural members makes up the self-weight of the structure. And what are the structural members? They include the columns, the beams, the roofs, the floors. They make up the structural members. And also, that ain't the only type of dead load that we have in structures. We have also the permanent partition walls. We have fixed permanent equipment, and we have weights of different materials. We also have immovable fixtures such as built-in cupboards, plasterboards. We also have your ceilings, your stairways, your electrical systems, your plumbing, and so on and so forth. Now, there's something to note. I mentioned weight of different materials. Now, building materials are not dead loads until they are constructed into permanent position. You get that right? So I hope you understand now what dead loads are. Moving on to the next one, which is live loads. Live loads are also called imposed loads. They are usually temporary. Unlike the dead loads, which is permanent, live load is temporary. I want you guys to hold on to those keywords. Dead load is to permanent, as live load is to temporary. As dead loads is immovable, live loads, they are movable loads without any acceleration or impact. These loads, they are assumed to be produced by the intended use or occupancy of the building, including the weights of movable partitions or furniture. Live load depends on the intended use or purpose of the building. A residential building, for instance, if it's going to be occupied by a family of 4, that the intensity of live load is not going to be much as a church where we have thousands of people. Live load could be in different forms. It could be in human form, it could be in vehicular form, it could be in the form of furniture. There are so many types of live loads. For instance, a structure, say a bridge, for example. The live load for that bridge is the number of cars that are passing that bridge. That is the live load. It's temporary. It's not permanent. It doesn't stay there. It keeps on moving. That is the live load for the bridge. So that is why a major load that is used in design is the life load. That is why we say life loads depends on the intended use or purpose of the structure. You cannot compare, I've said that before, I'll just say it again. You cannot compare the intensity of life load of a residential building to that of a supermarket or to that of a church because they vary. Okay, for instance, let's use an office. The intensity of life load in an office during the week is different from the intensity of life load in that same office during the weekends, because people tend to go to the office more during weekdays than the weekends. Those are the things to put into considerations when you're talking about designing a building. That should be enough explanation for life loads. I think by now we should know what dead loads and life loads are. That brings our wet duvet and rope line example into this context. I'm guessing you guys already know the answer. The poles are the permanent loads, which are the dead loads, while the wet duvet is a life load which is uniformly distributed along the rope. Okay? Yes. Moving on to the environmental loads, we have the wind loads, we have the earthquake loads, we have the earth pressure, we have the snow loads. Now, talking about snow loads are loads that are imposed by the accumulation of snow, and it is of more concern in geographic regions where snowfalls can be frequent and heavy, for example, the United States. Yes, so moving on to earthquake. Now, an earthquake constitutes both vertical and horizontal forces on a building. When earthquake occurs, the ground surface moves in both directions. That's what we're made to understand. Moves in both the horizontal and the vertical direction. Now, the magnitude of the vertical component of the ground motion is usually small. That means the vertical movement of the ground during an earthquake is usually small and it has little or no effect on the building compared to the horizontal movement. Now, the horizontal movement causes a lot of structural damage that must be considered in design of structures located in earthquake-prone areas. Now, talking about wind loads caused by movements of air relative to the earth. One major factor to consider when we are dealing with wind load is the height of the building. Now, wind load is not considered for low-rise buildings, it is only considered for high-rise buildings. And also, other factors include the velocity of the wind and the size of the building. So that will be all for this lesson. Don't forget to like, subscribe to my channel, and also drop your comments in the comment section. I will respond to all your comments and your questions, if any. That will be all for today, guys. Be ready for another fun-filled chi analysis lesson. Okay, bye.